Welcome, everyone. So this is Critical Tech Talk 12 and vibe coding and mini medical machines. So before we get started, I just have a few preliminaries. As always, I need to thank some people, and then I'll go on and do some introductions, and we'll get underway. So we're going to have today a 20 to 25-minute talk by our guest speaker, and that'll be followed by a conversation with three panelists from the Faculty of Health. They'll be sitting up here and they will have a conversation, and you'll have a chance to ask questions. And people on Zoom, you can also ask questions, put them in the Q&A, and I'll be watching for those on my phone, and I'll answer those as well. So I need to thank the Office of Research for funding this Critical Tech Talk series. We've been doing this for 2 years, and we had 12 talks, and every faculty on campus, 4 years, every faculty on campus has co-hosted one of these talks. So every faculty has kind of bought into this idea of honest talks about innovation and talk about innovation from different angles, from voices you don't always hear. I also want to thank Wendy Philpott and Olivia Vanderwall in the Faculty of Arts Communications Office for promoting this event. And then finally, Chris Rogers, who has been instrumental in making sure that all this stuff works, who's always in the hot seat to do that. So thanks, Chris. So this talk is co-hosted by the Faculty of Health, obviously. And I just want to say before we start, we're meeting on the Haldimand Tract, and you've all heard this before, traditional territory given to the Attawandaron, Anishinaabe, and Haudenosaunee peoples. And over the course of the 2 years of Critical Tech Talks, during these land acknowledgements, I always try to relate them to what we're doing during our talk. And today it may seem a little bit far afield. Well, we're talking about vibe coding and AI. What does it have to do with Indigenous folks? But it all has to do with Indigenous folks. So we are on their land that was wrongly ceded. And we're actually, when we talk about AI, a lot of the talks have been about the extraction of resources from the land that is required to run data, to actually build electronics and to use water for cooling data centers, and the data centers themselves they're people who are releasing carbon into the air and so on, have huge carbon footprints. So these are all quite relevant, and these kinds of environmental issues replicate a lot, and land issues related to where these data centers are and where the minerals are replicate a lot of colonial legacies that make our land acknowledgement all the more relevant. So this idea of environmental issues related to AI is not unfamiliar to our speaker, Dr. Joshua Del Papa. Josh is a resident physician in Diagnostic and Molecular Pathology at Western, and he completed medical school as well at Queen's University, and he holds a PhD in biochemistry from the University of Ottawa. His research bridges diagnostic dermatopathology, physician-centered interface design, and artificial intelligence with a focus on transparent, these are keywords here, transparent, clinician-empowering tools. He's currently developing a fully online AI platform that classifies skin cancers in real time. We'll hear a little bit about that today, as much as the IP will allow, I think. So Dr. Del Papa will speak to us for about 20 minutes, and then I will introduce our panelists, and we'll continue with the conversation. Please join me in welcoming Dr. Joshua Del Papa.
Hi, how's the mic? Everybody hear me? Excellent. Okay, I'm just starting a little timer here so I don't get, I heard 20 to 25 minutes, and I'm going to try to stay true to that. So good afternoon. My name's Josh. As Dr. O'Gorman here just said, I'm a third-year resident in Diagnostic and Molecular Pathology at Western University. As residents, we call it pathology. And I am so excited to be here to share a bit of my experience in the sort of with what I've been able to do and what I've been able to unlock with vibe coding and some of the tools I've been able to build with it. I think it's Oh, I should also start by saying, I believe, unfortunately, due to a bit of a technical glitch, those of you online who are zooming in are going to miss out about the last third on the right side of the screen. So if you're confused about something I'm talking about that you can't see, that's why. So I figured I would start with a bit of a background on how I ended up here, and how I ended up using some of these tools. So there's two reasons for this. One is that I want to reemphasize the point that I don't have any formal training in computer science. And two, I think it gives it a little bit of a context as to where I'm coming from and where my background is and what my expertise is. So the first time I ever looked at a terminal or a console or essentially anything that wasn't a graphic user interface on a computer was in undergrad. I was involved in some really cool research where we were sequencing the gut contents of predatory fish, and we were looking at the DNA within the gut contents to identify prey. And as you would imagine, this is kind of a niche field, and there wasn't a program that we had access to that could just analyze the data for us. So I had to use some non-user interface tools. And I found it kind of frustrating and clunky, and I stayed away from a lot of coding after that. So next, after undergrad, I pursued a PhD in molecular genetics in Ottawa in the lab of Dr. Robin Parks. He's a virologist, where I did a lot of my work focused on engineering oncolytic viruses. So basically taking a virus and trying to make it better at targeting and killing cancer cells. And as a lot of you, I suspect, in the audience know, in grad school, a lot of people learn how to use R or different sort of analytical softwares that require a bit of coding knowledge to look at their data. I stayed as far away from R as I possibly could in grad school. I heavily leaned on graphic user interface programs. Specifically, the one that saved me countless times was called GraphPad. I built all my graphs in there. Ran all my stats in there. So I was far from comfortable coding at that point. I next went to medical school at Queen's University in Kingston. Again, didn't touch any code in med school. In med school was the first time I ever heard the word ChatGPT. And I remember hearing about it at a party, and it sounded like this kind of sketchy underground service that was going to steal all my data. And I guess I was partially correct. And then after medical school, I started my subspecialty training in anatomical pathology in Western. And so in anatomical pathology, what we do is we look at tissue like this. And normally we don't look at it on a digital, this is a digital image of tissue, a digital image of skin. Normally we look at it analog, we look at it under a microscope. And our job is to identify cancer, make a diagnosis, write a report. And so that's what I do that's what I'm basically training to do, is a diagnostic medicine. And I had to look this up because I wanted to get this right. And I was going to say that Darwin talked about how you have to have selective pressure in order for evolution to occur. And it wasn't actually selective pressure. He said, I think it was like a struggle for existence or something like that. And for those of you familiar with medical residency, there is a little bit of struggle for existence there. And I think that's where I kind of started to evolve, and I became a bit of an underqualified software engineer. And then most recently, unfortunately, I can't talk a lot about it, but I have this sort of, I'll keep using the term vibe coding. I don't love the term vibe coding, but that's what everybody calls it. So that's what we're going to call it today. Vibe coding has unlocked the capacity for me to join a startup in health tech. It's very early phase. I'll tell you as much as I can about it a little bit later. So what is vibe coding? This is kind of a conglomerate of definitions I was able to glean on the internet, but essentially, vibe coding is using plain language to instruct an AI tool to generate code. Like I see it as a translation service from English to Python or C# or whatever other language that you're coding in. And to me, I mean, there are lots of use cases for this, and this is not universal, but to me, I feel like in my practice and in my work and my research, vibe coding has targeted the gap. And what I mean by the gap is the gap between massive corporate needs and end user workflows. For example, I don't know the details, but I suspect that the hospital I work at spends thousands and thousands of dollars on our electronic medical record. But for me to prescribe Tylenol to a patient, it takes 7 or 8 clicks. And if I get one of those clicks wrong, it may not go to the patient, it may go to another patient, or I may get double the dose on accident. And that it's just silly that that's the case. Whereas there are specific end user workflows that are they just not part of the conversation as far as building the tools that they use. And I want to emphasize this, and I'll try to keep emphasizing this throughout the talk. But to me, vibe coding is not about scale. And by scale, I mean it's not about commercial scale. And I'll define that one more time. What I mean by that is I wouldn't want to give any of the tools I've built to anybody else to rely on in their day-to-day practice without having an expert, and by expert, I mean somebody with formal training in computer science, have a look at that. Because I may know that the input is good and the output looks good to me, but in between, although I've learned a lot throughout this sort of journey, expertise is critical. I don't know if anybody here recognizes this guy. This is Rick Rubin. He's kind of a legendary record producer, and he's somehow been mixed up into the world of vibe coding, and he's been co-opted as a little bit of a figurehead in some ways. But he's quoted as saying vibe coding is the punk rock of software. And in some ways, it's very not punk rock, but in some ways, it kind of is. It bucks a lot of trends and it makes people upset. And so I think in that way, it is kind of punk rock. So I just want to show you some examples of some of the commercially or the available models that you can use to vibe code. And the simplest vibe coding platform are the large language models, right? Like Gemini, GPT, ChatGPT, Claude. Asking them to write a Python script for you is the simplest iteration of vibe coding. Here's an example of, and then there are also now companies that are coming out that are trying to make this a more user-friendly journey. So on the left here, this is an example I kind of generated. I gave it 4 lines of text. I asked it to build a lo-fi beat soundboard. I gave it some basic instructions, and then within 2 minutes, it had generated an app that I could click and test. It's kind of funny. It obviously couldn't find a source of rain or forest or fireplace sounds, and so it tried to mimic it with white noise, and it did a terrible job, but it was still kind of interesting to play with. And then on the other end of the spectrum are these tools that are more geared towards people with a background in computer science or specialized talents in computer science, where they can actually see the code that's being generated, or maybe they started with code that they generated themselves, and they interact with a large language model on the side to maybe learn about the code. Maybe they want to improve a section, or they want to ask, what exactly does this chunk of code do, and how can I make it better? And so, the message here is that the tools run the gamut from very, very simple iterations to much more, geared towards people with a formal training in computer science. So I think the best way to show you about my experience is to show you the things that I've been able to do. And so I'll start with an extremely simple tool. It's a Python utility I built with the help of large language models. So I'll tell you about a lot of these projects started with me just being annoyed with my day-to-day process. So as a pathology resident, these are slide folders, and there are 20 slides per folder. And in a typical day, we might get 6 of these folders. So that's 120 slides. And within those slides, there might be 80 specific cases. Depending on the day, for example, if you're on the skin service, 50 of those cases might be squamous cell carcinomas. It's a very common diagnosis, and it's very commonly biopsied. When I get a squamous cell carcinoma diagnosis, these are the pieces of information that I need to include in my report. And as you see, this isn't a very long and descriptive report, but there are very key pieces of information that if you forget one, it introduces like the physician who has taken the biopsy is going to be missing a critical piece of information. And I may have to do this 50 times in a day. And so you can imagine typing this out 50 times is just a huge waste of my time. This is time I could be using looking down the microscope, learning more about the tissue, or studying from a textbook. And now you might think this is a really simple problem. There's a solution to this simple problem. And there is in our department. It's called Dragon. I don't know if you guys are familiar with Dragon, but it's basically a voice-to-text software. So staff physicians dictate into Dragon, and it will dictate the report for them. You can even program in canned pieces of text into Dragon. So you can say, insert SCC for squamous cell carcinoma, and it would automatically fill these things in, and then you just fill in the details for the case. But the problem is that, so here's an example of sort of end user experience, right? So the pathology residents, we work in a large room, in a Carroll's. And so if we were all dictating into Dragon at the same time, it would become a zoo. None of us would be able to hear each other. None of us would be able to focus. And so we don't have access to the tech. And so I said, why not just build something? And so I did. So basically, I used Python and large language models to build my little app called Pathwords, which I thought was kind of clever. And it allows you to build canned text libraries. So it's just a video. So you can open it up. You can see the canned text that you have. You can edit them, add new ones. And importantly, you can import and export. So it imports and export as like a JSON file, and you can share it with your co-residents, the people you work with, and they can all use the same canned text. And it's super simple. You use any, for us, it would be a particular piece of software. Here's a text editor. So you type your code, and then you hit Control Space, and it replaces it with the canned text that you have built into the library. And so again, really simple, but a tool like this would save me like 30 to 45 minutes a day, depending on the service, which is, huge, and it was free. The idea is this could streamline my workflow, reduce my documentation burden. However, the hospital IT department is really on the case, and I got a cease and desist letter about 5 minutes after testing this on the hospital computer. And they said, what is this sketchy Python script you're trying to run on our computers? And so I sent them the code, and it's undergoing a security review. So hopefully soon I'll be able to use this and share it with my co-residents. The next tool I built, admittedly a bit of a step up in terms of complexity, but ultimately I learned a lot while doing this, and I'm still learning about this tool. And it was a really cool experience. So I'll tell you a bit about frozen sections in pathology. So frozen sections are rapid intraoperative consultations. So this is when a surgeon cuts a piece of tissue, sends it to you, and says, hey, I need to know if there's this cancer, and I need to know in 10 to 20 minutes, because the patient is still on the table, they're still under anesthetic, and time is critical. A lot of these frozen sections come to us because they're taken from areas that are critical. So for example, this might be a basal cell carcinoma on this person's eyelid. And you can imagine if this was you wouldn't want them to take too much tissue from this area, right? This is a critical area. You need to be able to close that eye. But at the same time, You really don't want them to leave cancer behind because that cancer could grow, it could invade the orbit. You may end up losing the eye, it could metastasize somewhere else. And so it's critical for us to identify with great accuracy and very quickly whether there's cancer in a specimen we receive in frozen section. And so I thought this would be a perfect opportunity to use some of the technology that's recently become available. So around the same time, this paper was published in Nature Medicine about a model called VerCow. And so VerCow was developed by Page AI, and it's a foundation model. And what it does is it turns little pieces of a picture, a digital whole slide image, into data or embeddings. And I'll get into that a little bit. But what I did was I started by, admittedly, I started by asking ChatGPT, how can I do this? Can I run VerCow on the computer that I have? And if so, how can I leverage that to train a local neural network to detect cancer in a specimen? And so it basically went from that question plus hours and hours of stubborn back and forth to something that turned out to work pretty well. And I'm going to share that with you next. So this is kind of a bit of a map on how the project works. And I mean, I could talk about this for an hour. And if anybody has any questions about this, I'm very happy to chat more about it. But basically, you start with a whole slide image. Okay, so these are whole slide images. These are both skin. And you break them down into tiles. So these tiles are 512 pixels squared. They're really tiny. And each tile gets fed into VerCow. And what VerCow does is it translates the image into embedding. So it translates them into pieces of data. So 2,560 values per 512 pixel squared tile. And what I next did is I took that data and I said, okay, I have 10,000 tiles with all of this embedding data that are basal cell carcinoma. And I have 10,000 tiles with all this embedding data that are normal skin. And I basically inputted those into a neural network in order to train it to give me this. And so now when I put in an unknown tile, the neural network will say, okay, this tile, based on the tumor probability, is 84% similar to the tiles that you said were basal cell carcinoma. And this tile is a lot less. And so if you combine that with the coordinates of the tumor, or the tile, sorry, you can build heat maps. And so I'll show you a little bit about that. So here's a skin specimen. And this is the heat map that my tool generated. So it says it doesn't think that there's any cancer here. There's no red marks indicating cancer. And upon close inspection, this is a negative piece of skin. This one, on the other hand, it may look a little bit busier. There's this kind of dark brown, purpley stuff kind of flowing throughout this area. You don't have to see it. You just have to believe me. And the tool identified this, and it did it really well. So you can see that it's identifying local areas where it's worried that there might be cancer. And ultimately, the tool was actually very sensitive when gated properly. And that's what we want in a tool like this in pathology. We're looking to build tools that basically fill in where a pathologist may fail, right? And so pathologists are extremely specific in our diagnoses. So it's very unlikely that I'm going to call something positive when it's negative, okay? However, it is possible that I miss a tiny piece of that slide that had a tiny piece of tumor on it. I didn't see it, and so I missed it. I called it a false negative. We built this tool to be the opposite. So here's the way to look at this graph is, or this confusion matrix, is that there were 58 true positives in the data set of 211 slides. All 58 were called positive. None were called negative. meaning it was 100% sensitive. There were 153 true negatives in the slide test set. 21 of those were called positive. But that's okay, because when you give this to a pathologist and you say, hey, this area is looking a little bit sketchy, have a look. The pathologist has the capacity to go in, target that maybe they've already said, I don't see anything, but the tool has kind of alerted me to this spot. I can look at it and say, no, I stand by what I said, it's negative. But it may help them catch something they might have missed. And then for the last not so mini medical machine, unfortunately, I can't share a lot about this. It's very early. But I will say, I think historically, the startup space, not historically, in recent years, the startup space has been locked behind computer science expertise, especially for people with specific domain expertise, like those of us in health. I was, because of my development of the basal cell carcinoma tool, invited to basically lead development and build the full stack first iteration of an AI first app in healthcare. And I have to say, it was kind of incredible how quickly I was able to bring the team's vision to life. I would meet with them in 1 week and they would tell me what they kind of wanted to see. And then I would meet with them the week later and show them what they wanted to see, and their jaws would drop and they'd be like, how are we doing this so quickly? So it worked out. It was looking pretty good. But like I said, I don't think vibe coding is built for scale. And so now we're collaborating with real experts. We essentially built a prototype, and now we're collaborating with the people who have the expertise to look through it, give us a stamp of approval, and hopefully I'll be able to share more with you soon. So in the spirit of the critical tech talk, although this is not my place of expertise, I think it's important for anybody using any tool to have feelings about what they're doing. And I thought I would share with you my thoughts on using these large language models to do what I've been able to do. So on one hand, I have objectively gained agency in my workflow as long as the hospital allows me to use this Python utility once it gets through security review. But on the other hand, I'm using tools developed by big tech. So is it really gaining agency when you're paying ChatGPT $30 a month to acquire that agency? My process is leaner. I think the basal cell carcinoma identification tool that I built really could save money and time. And I really do think with implementation and with enough reps, this tool could save a life. And if not save a life, save somebody from having too much skin removed from their face. But at the same time, I know that these large models have a huge environmental and social impact. And so I have to balance these thoughts, and I'm not really sure where I stand. Then I start to think, well, this tech is ubiquitous. It's available to everybody and it's out in the open. Is it ever going to go away? And if not, why shouldn't I use these tools at my disposal to make my work leaner and maybe improve healthcare? But then, is my $30 subscription to OpenAI actively contributing towards the activation of Skynet? So these are the things that I think about. And I think we're kind of in a very, I think we're in a time where a lot of people feel that there are sort of extreme areas or extreme directions that we're going in, right? And a lot of the times it feels like AI is an extremely, it doesn't feel like it is. It's an extremely extractive and consumptive process. And at the same time, however, these tools do allow for a significant unlock. And so in the right hands, could this tool, allow for the activation or the generation of transformative technology that could potentially lead to, a future prettier than the one on the top? Ultimately, I must admit I'm on the fence, and I'm really excited to discuss today with you all and with my co-panelists about what we all think. So I have to finish with an acknowledgement. Dr. Machikini is an AI guru in our department, and he is working tirelessly to push pathology into the future. And he has been a mentor to me in this field. And I wouldn't have been able to do any of what I've done without his sort of support and guidance. So thank you, Dr. Cicchini. And I have a question, and obviously, our discussion today is going to evolve organically. And you don't have to answer this today, but maybe just think about it. Maybe it can be a thought experiment. If you had the tools to develop a piece of computer software in your own field that might make your day better or make you better at your job, what would you build? And if you come up with a compelling idea, maybe ask a large language model if it's feasible. Thank you very much, and I'm looking forward to chatting with you all about this.
Thank you, Josh. All right, a lot to think about there, and I can see you've cued in your talk to the Critical Tech Talk vibe, so appreciate that. So now I get to introduce our panelists today, and all three are from the Faculty of Health. And I'm going to begin with Dr. Helen Chen, and I invite you all to come and sit up here with Josh, and we'll continue the conversation. So Dr. Chen is director of the Professional Practice Center in Health Systems and serves as program lead of the Master of Health Informatics program. Dr. Chen's research explores the application of machine learning and generative AI to enhance the accessibility and usability of real-world health data, supporting evidence-based decision-making in healthcare and public health. So thank you for joining us, Dr. Chen. Dr. Jim Wallace is professor in School of Public Health Sciences with a cross appointment in the Sheridan School of Computer Science. He's published widely on topics including human-centered design, games for health behavior change, and AI support for qualitative research. So thanks for joining us. And finally, Dr. Plinio Morita is director of the Ubiquitous Health Technology Lab, or the UBI Lab. His research interests are in the areas of population-level surveillance using IoT data, mHealth, and wearable technology design. Every time I read that, I'm like, population-level surveillance, it really makes me itchy. All for the sake, he also works with ubiquitous sensors for smart homes, usage data and health data analytics, precision medicine, and technology for aging, all from our Faculty of Health, these people. So it's fantastic to have you here today. Please join me in welcoming them. So this works best when I don't talk at all. And so I'm going to give you an opportunity to talk, but I may intervene now and then to ask some questions. So I'm just going to pass these mics around. Did you turn this on, Chris? I think. No, I got it. Josh doesn't need one. I'm just going to have you share the one mic. It's more convivial if you do that. So I assume you have some questions for Josh, so I'll just let you go ahead and take the floor and just start chatting a little bit.
So I'll go first. Be happy to. So it's very interesting to see your experience using these tools without having a background in computer science, because that's the reality of a lot of our students in our programs, right? Like we have two major undergraduate programs like health sciences and Bachelor of Public Health. And a lot of our students are interested in software development, but they don't have the background. They're not trained for it, right? Like, and computer scientists spend years in going through their programs. Like probably several of you here have come from a computer science program. So my question for you is if you could give us a tip on how to make this more accessible and easier for students to start using, what would you suggest?
That's a really good question. I think a lot of my work kind of evolved organically. The first, like I talked about that Python utility, right? But my intro to this stuff was really just asking ChatGPT how to format an Excel file. It started with how to write the code in order to copy, every second box or something like that. I don't remember what it was. And then it kind of evolved into, okay, well, maybe you should use a VBA macro to do that. Well, like, what's a VBA macro? So like I would ask, and I learned what a VBA macro was. And so I said, well, here's what I need to do. How can I do it? And like, it sounds kind of crazy, but I did spend a lot of time going back and forth with ChatGPT or whatever LLM, you name it, learning about this stuff before just being like, okay, write a code to do it, right? So I think my suggestion would be ask a lot of questions, and not just the LLMs, because obviously you have to be very critical of what they tell you. Uh, but back up your research with the enormous amount of data that's out there. There's forums, there's textbooks, or what have you. But ask questions about what you want to do. Like I said, if you can come up with something, a piece of software that would make your work flow better, just ask an LLM if it's feasible, if that's something that it thinks that it might be able to help you write.
So I'm a human-computer interaction researcher, and I have a background in computer science. And I wouldn't trust software that I trust you more than myself. So I just to put that out there. I was blown away. I found this really interesting, and I just love this idea of kind of rapid prototyping and exploring ideas. And I would say that from my position, I'm a bit of a middleman. And what I see when you're talking like this is you're cutting out the middleman and getting it to this software design and being able to really imagine what the software should look like, and then potentially involving some people to fine tune and kind of get it deployment ready. And so I guess my question is, when you are founding these companies, what does your kind of ideal design team look like? Like, what does that company look like, without sharing too much IP information, but from like a personnel perspective, who do you want to be in the room kind of building this stuff?
Yeah, that's a really good question, and a question we're learning the answer to as we go. We're stumbling through that question as we speak, because I think it's a very new problem. And I mean, it's a problem, but it's also like a huge opportunity. So I think one way I would do things differently is that I would have had an expert in the room much earlier. We built a prototype, but then I kept going, right? I went and built a full stack app, and I spent a lot of time on it. And I found out that there were some major flaws in the app down the road later on, which I wasn't able myself to uncover, right? And so I would say in the room, you need somebody, you need a specialist, you need a computer science trained individual. Maybe that person isn't fully invested as you are. Maybe they are only doing it on the side, or maybe a couple hours a week, rather than being in the trenches and building from the ground up. But they need to be in the room from the beginning. And then you need somebody like me who is just stubborn and finds this stuff fun, because otherwise, like none of this stuff would have happened if I didn't find it fun. Because at the same time as I'm working on these things, I'm also in residency, undergoing training, and so this is like it's been a lot of work, but it's a lot of fun. So you have to have somebody who's really into the idea of building stuff, and then you have to have the visionaries. So that's what I would say. If you're building a team, you have to have an expert, you have to have somebody who's stubborn and willing to get in the trenches for hours, and then you have to have people with a vision.
Cool.
Yeah.
Thanks.
Yeah, and you really it's so exciting to sit beside you and validate some of that. It's just incredible. And then physicians and the writing codes, writing the entire EMR, it's not too unheard of. They are having those physicians are very motivated and wants to do those things. But now I feel like what your experience is that you use this large language model really to, I almost think that democratized this software development and these tasks, and which is extremely needed. I remember the first time when I come to Waterloo and having a collaboration with a very renowned imaging processing researcher, Dr. Alex Wang. He is really very famous. And there was actually talking about exactly the same problems of the melanoma detection.
Okay.
Okay, those years. I published lots of paper, but but I don't think they come down to residents and of the 11th hour can do something like this. Because fundamentally, the large language model of the imaging processing changed that to the level of the ground. So that's what quite a few of the students here actually. was the last year we're learning AI for public health, and they were doing the same thing. They said, so you have to go ask ChatGPT because lots of them, just like yourself, and ask ChatGPT. So, in a sense, and we have the two camps on campus. Some of them are really, really against teaching the students in this way because they feel like they will actually good foundation. So then they banned that use, and then other camp, and it was very enthusiastically embraced. So what do you think for the students actually learning, and to say whether learning with the ChatGPT style, will that diminish your critical thinking, or with that actually giving you, I like the way you're saying, giving you the agent, and then now you have more tools in your hand and drive you faster. So what do you think from the education point of view? Because I always encourage my students that are awesome, they're sitting here, so go to ask ChatGPT. but I have to hide under the table in the Waterloo campus, really. So I'm glad that you are here. So, but what do you think to the students in this? I think Beth just about to join us. I was coerce her to go learn programming in a similar fashion. So what do you see people like this?
Yeah.
Will they actually encourage them to go learn?
Right. So that's a good question.
Yeah, also has to be actually be aware you are learning with ChatGPT either to make you kind of dumb.
Yeah, I mean, I think ultimately that's the key, right? And so I can only speak from my own experience using the tools. But what I can say is that I have both equally learned a huge amount about coding, about Python, about different languages, about how software is built. But I have also been led astray. So there have been times where I have spent 6-7 hours working on a problem that, number one, is already solved, and it's very simple to anybody with formal computer science training, or two, I'm going about it in an extremely obtuse way, and I am not aware of that, right? And so I'm banging my head against the wall. And so I think you need to be careful if you're learning with these tools. I think you have to have kind of like the dream team that you were asking me about to sort of start a project in this space. I think you have to have a balance of both structured formal education, or at least access to structured formal information, at the same time as using these tools as basically a sandbox to explore. And like, I learned so much about Python and TypeScript by looking at the code and asking Claude or, what have you, what does this piece do? And so in that aspect, I think it's a huge, it's incredible teacher, but ultimately you just have to be careful, and you have to know and know when to reference like formal sort of sources.
So would that actually inspire you now to come back to the school and then enroll in the computer science? I have quite a few students like that, really. I'm not exaggerating.
I honestly think that's if I hadn't already spent like 300 years in school, it would definitely be on my radar. I would love to spend some time developing a stronger background. And you know what? Maybe that will happen. But in the meantime, I'm really happy to collaborate with people who know what they're doing instead.
Can I ask a related question? Would you come back to school to study technology and ethics?
That's a good question. Yeah, I would. I would. Part-time, if I was 1 hour a week.
Okay. This is related to a question from the audience. So this is coming from actually a colleague at the Ottawa Institute, or sorry, the Ontario Institute of Technology is asking that they're basically saying that they're impressed that you're dealing with these ethical conundrums and wonder how deeply you go into thinking about that. Are you drawing, where are you learning about this? And are you drawing on any other ethical, cultural, historical, social contexts to think about what you're creating? And she said, could you possibly see yourself not just as an early adopter and sector expert, but also as someone who's pioneering, who could possibly pioneer AI ethics in your field?
I love that question. I am extremely underqualified to call myself anything close to an ethical pioneer. However, I mean, things like being invited to participate in this discussion. I don't think anybody who uses these technologies doesn't wonder about the impact that they're having. But I do think that using them as much as I have been using them, I think you do have a bit of a responsibility to at least explore the ideas that other people have, and this isn't, you know, I'm aware that this isn't a tiny sort of swath. Like, this is a huge swath of the population that are really smart and are really thinking about these technologies critically, and so. Up until now, I can honestly say that no, I haven't done, aside from the, you know, large scale media that I consume on whatever, on Reddit, about, you know, the horrors of what ChatGPT is up to. I haven't done enough digging, but I have been kind of inspired by being invited out to this discussion, and I do think I plan to do more.
Great.
And yeah, I think it's and to answer the last part of that question, I'm not sure. Maybe. Well, we'll see how.
I think what they're saying is it's kind of an opportunity to say you're going to build this thing, but you're also going to build it in a way that is according to edicts of responsible AI.
Right.
So that's you don't have to answer that now. We're not going to put you on the stand. Jim, I wonder if you had any comments about this idea.
I don't even know where to start. You know, a lot of the work we're doing in my lab right now is using these in areas. So we do a lot of work on qualitative research. I'm editing a thesis right now. And what we're finding is that people tend to trust the AI too much. And so I don't know if this is ethics, but I think a lot of the questions here are just over reliance and over trust and getting people to think about when to question it. And so when you were talking, Josh, about the complementing the doctor's expertise, I thought that was just a perfect way of meshing AI and people. And I think in a lot of places it's being applied in cases where that's not true. And so I would like to, I have been prompted to think about this more because it's not something that I've been doing, but I really appreciated that.
Thank you. I will add one thing. I think, like, having gone through research training and having gone through med school, my frame of ethics was largely, I mean, you know, aside from like my frame of professional ethics is largely sort of forged in medical school in terms of like medical ethics. And so when I'm building these tools, that's something that's at the forefront of my mind, right? It's the ethical use of patient information. These are things that I think about, and these are things that I have been trained to think about and that come naturally to based on my background. But there's, I think, a bit of a bridge between medical ethics and the ethical use of AI. And I think they're both important in this kind of technology, but I do think like I'm more on that side, and I've dipped my toes, but I haven't dived in it.
I have colleagues here, we teach engineering students, and we found, it's found the same thing in engineering. Engineering ethics is not the ethics of technology, not even close. So I think it's a similar kind of problem. Do we have an audience question? Oh, okay.
I just wondered, when you're using these tools, especially in the medical realm, who owns code? So is there any, concern that the LLM that you're using, like, is it theirs? Is it yours? Whose intellectual property is it? And especially when you're using it related to the ethics thing, so I thought I'd ask this question now. Like, is that a concern? I think it's great. And I think it has, on balance, a lot to offer. But I wonder if you've ever come across that, particularly in your startup realm, where that might be more of a, front concern. Is it yours?
Right.
And when you use it, owe any money to the LLM who helped create it?
I just want to get this for the Zoom people who may not have heard. The question is, who owns the code? So is it your code? Does it belong to the company who's platforming the LLM? And do you worry about that?
Yeah, that's an incredible question. And I certainly don't have a succinct answer for you. I can tell you that I feel like I deserve to own some of the code. I have spent hours and hours forging it through sort of sheer, I guess, being stubborn and kind of learning as I go. That doesn't answer your question, though. I think ultimately, like, I think of this the way that this isn't something I have sat and thought about long and hard, but when you say those words to me, like, what goes through my mind is, well, there are infinitely large pieces of data. Infinite is a bit excessive, but there's a huge amount of data that's getting processed at the same time in these LLMs. I suspect that there isn't somebody who's interested in this small TypeScript app that I've built. That said, I'm sure this topic has been broached in other fields, in generative AI and large language models, and I'd be curious to hear from somebody else about it.
Yeah, so in a way that if you, I don't have an answer, but then just provide some way of thinking, is that consume a service which is made by somebody else is very common, and every actually part of our software, the EMR, and they all have that component. Okay, so the large language model LLM is another, you can consider them as another service model you call, right? So there is a certain license and you pay them fee anyways, right? So these ones are part of that. Is not a new problem. So to you, to your thing. But there's one thing you need to pay attention is that now, because you need to use their services, lots of them require you to upload the data in order to get parsed. So that is how you're going to draw that line. And with your system, your patient systems, and the data has to go where they go. Sometimes it goes to somewhere you want to have a tighter control.
Right.
So that is a new area.
Yeah.
But again, I guess the code, you own the code, right? That's for sure.
And this is the reality in software development around the world these days, right? Like if software development, for those who don't work in this space, developers use communities, online communities, a lot to find relevant code, tips on how to solve a problem, right? Because again, as you mentioned, someone already solved this issue. Why am I going to spend like a week working on this if I can learn from someone that has already worked on it? So it's just a different way of accessing that information, right? Now you're using an LLM model to generate that. And the reality is that the LLM model built your code based on those recommendations that are online and recommendations that people have already given in the past, right? That's how the models actually learn so much over the years.
Yeah.
Start with the back
Hey,
there.
let me bring you a microphone. So it's per the Zoom.
Thank you. So I work in the industry. I pay for these services on a daily basis. The code that you generate, regardless of whatever you generate, you own, right? And this is coming from the guarantees that big companies are providing, Google, OpenAI, Anthropic, for example. However, as Helen mentioned, the data that you're sending them, depending on what service level you're using, they may be using that data to train their own models. So it's not about the code. Whatever you generate, you own, but the data that you're exchanging with them is the legality of that data and the privacy and sensitivity of that data, right? And then there are services that if you pay for it, then that data is confined within your own organization as opposed to shared with everybody else, and they won't train on it. But those are all legal guarantees. There's no specific computational guarantee that they can provide that it'll work that way.
Thank you. Oh. Did you? Yeah, you had a question. I thought so.
Thank you for the talk and the conversation. I have two questions, but I'll keep it brief. How much of your training do you think your training as a PhD before med school has helped you be more open to vibe coding? So how much do you think that has helped you have kind of a problem-solving, scientific thinking approach? And also, as you mentioned, you have experience in medical ethics. So how much of that training helped you to think critically about what you're doing compared to someone that probably has no exposure to ethics, whatever? So because something about AI and the future of education is if anyone can learn it on their own, do we need to teach them in the classroom? But another approach is that maybe it's a way of thinking we are teaching in the classroom, not necessarily the content. And then the second question is mainly about this concept of AI designers embedding their bias or their opinions into algorithms. The fact that you started with how do I copy this in Excel, and it's like you could write a script, because sometimes I ask ChatGPT stuff and I'm like, there are simpler ways, you're giving me the harder one. But how much of the scientific thinking of the programmers, and that could be a good thing, like we know that they already embed their bias, but maybe it's a way of spreading scientific thinking or problem solving thinking, because if I train something, I tend to do it, the thing would work the way I think, right? So those are just a couple of thoughts I had.
Yeah, thank you for that. To answer your first question, or to try to answer your first question, I don't know, to think sort of critically about it, I think my experience in grad school probably forged, yes, like scientific sort of way of analyzing problems, but also it forged the sort of I try to, this is said too often, but I try to work smarter and not harder, right? And so I look for, I think because of grad school, because time is limited and there's so much to do and so much to learn, I kind of learned to look for not shortcuts, but ways to make my workflow more efficient. And so that's probably what pushed me towards using these tools. But I think that's a really insightful point. And I do think that there's a bit of a back and forth with me, like, sure I come from it from a scientific perspective, and that's how I would naturally try to solve a problem, but I'm also kind of learning from it based on how it suggests that the problem is solved. And so I think that's totally, I like that idea. And I think the second part, I might have blended both parts of your question together in one answer. Okay.
Thanks. There's a question over here. On my way over there, I want to ask a question as well. So Josh, you showed us a picture of some skin cancer a minute ago. My question would be, whose face was that? And this is a data question. So the question is, we talked about who owns the code, but who owns the data? Where is that data coming from? And do the patients, are they aware that this data is being used in this way? And I'm thinking about maybe finding outlier data, for example. I'm thinking of Henrietta Lacks is what I'm thinking of. Finding outlier data of some sort and using it in a study or to train models and actually possibly gaining financially off of that, off of someone who's, skin cancer has been identified and so on. So it's a question of privacy and where does your data come from? And do you think it's right to have access to this data? And do the people who gave that data up, do they know that that data is being used in this way?
Yeah, that's really, sorry, does somebody else want to? Okay, all right. Okay, yeah, all right. No, I mean, I have spent a lot of time thinking about this, and this is kind of closer to my sort of framework of medical ethics when I approach these projects. And so a couple of things. First, when we designed this project, I was careful to never send any of this image data that I've showed you today to the cloud. So none of this data was ever sent off like online to ChatGPT. I never sent a whole slide image or a patient's name or any patient information. All of what I showed you today with my basal cell carcinoma identification tool is run locally on a machine and trained locally. So this is one way that we try to mitigate that issue. I think like traditionally in medicine, we think of patient data that's been de-identified as safe, right? Like their numbers, it's your lab values or the course of your treatment, and it all gets aggregated in studies that we can learn from it and improve medicine. But I do agree that we're getting to a bit of an interesting point where that image, the amount of data that we can glean from it is becoming exponentially greater. And like there are tools now that can look at a lung cancer, the image of a lung cancer, and predict whether or not it has a particular genetic alteration. And so who knows in the future whether or not we could reconstruct the way somebody looks based off of a single image slide like this. Like who knows what this tech is capable of. So it's a good question. I don't have a good answer for it, but I do think that it's not unreasonable to wonder whether this information is greater than what we give it credit for.
Yeah, it's a question of data sovereignty, which is a big question. And I do want to ask if you've tested this model with different skin color tones, but I'm not going to. I'm going to let Dr. Marita talk.
I was just going to add a small comment about this. One important thing to consider, right, is that what we're doing these days with a lot of this data is no different than what we have been doing over the past 200 years in medicine, right? The only difference is that now there is a more straightforward commercial path associated with it. Medical doctors have been in the innovation space for ages and have used their knowledge and their expertise and their data, not their data, the data they have access to, because ultimately the data is owned by the patient, nowadays owned by the patient, but oftentimes owned by the health organization that you work for or the institution that you are collaborating with. So one thing to consider is that a lot of the financial gain from these models comes from the insight of those data sets. But that's a very important question. Should we start thinking about pathways to compensate participants or compensate patients for their contribution in intellectual development as their data is being used.
Go ahead.
I think a main issue, that one thing that is different, is the AI platform middleman, where the data is, it's coming from, so if you're using a platform to generate software, to generate code, you're actually, at some point, that data could be exposed to that other platform and could be monetized by that platform as well. So that adds a middleman, could add a middleman to, depending on how you're doing it, to let this person talk and let you answer to.
But one thing to consider here is that, and Josh can speak more about this, the AI platform is being used to develop the software. The data itself is never fed into the AI engine, right? Like, it's just the software that processes it. Then he extracts the software, runs it on a local machine, and that is that, right? So all the data sits locally,
Correct.
protected, right? Like,
So, okay, so you are safe. So, so far.
Okay.
Because that's kind of a loaded question, get you exposed. But I want to actually take a look of another way of the way we use health data now. So traditionally, when we are teaching our first course for Master of Health Informatics course, and then we'll say, okay, well, there's a primary use, there's a secondary use, and then et cetera, right? So it's very clear definition, and then you want to use that for the clinical study. That's also REB and how you collect, how you destroy the data. Very, very clear. But here entering our AI domain, and then lots of data was trained in the foundation model you train, and you actually don't have the downstream task yet. You don't know whether we're going to develop a tool for diagnosis, prognosis, for monitoring. You don't know. So that line of usage of the appropriate use of the data becomes very blurred. And we don't have this kind of usage before. Before you said, okay, you can use it at the hospital and for QA and QI, that's okay. But now it's actually training the general model.
Right.
And to be determined what they use and who will make money. So that is a different way of using the data. We don't have a category for that use. So that's where I want to bring it here. Whoever wants to study the ethics, that is another way and has to be considered as well. We have not have a clear definition.
So I'm not an expert in this, and I'm still learning a lot. But I think a lot of us do research on things like Reddit data and trying to understand from this publicly available data what we can learn from a public health perspective. And so folks in my lab have looked at things like substance use communities, communities for people taking care of their older parents. We've looked at vaccination discussions. And it's interesting because from a ethics perspective, UWaterloo says it's public data, you can do whatever you want with it. I've had discussions with my students at the end of their degree, and we kind of said, well, like, we don't actually feel that right. Like, this is kind of, and so we've done a fair bit of investigation into this. My academic community has published quite a bit about this as well. And you can start doing things like looking at community norms. So like a lot of online communities will actually have a statement that says, feel free to use this for research, or we don't want you to use this for research. And so, and I would say that what we're doing is probably at a smaller scale than foundation model training, but they're all doing the same thing to go out and grab this data and learn more about how we talk about things. So I'm not perfect about this. Like I feel not necessarily that I've made mistakes, but definitely could think more carefully about how we're doing this. And I would just say there's a lot of literature out there if you are thinking about this, and to start being a little bit more mindful about how people have kind of signaled to you about whether or not the data is public or not.
My turn? Okay. Can you hear me all right? All right. So I'm going back to the code ownership issue a little bit. I think it's somewhat related. I don't think it's as simple as you own the code. So Google might say you own the code, and OpenAI might say you own the code. You have no idea where Google and OpenAI got the code from. They've trained it on a massive data set from all over the internet with probably a wide variety of licenses. Those licenses can have conditions where it is open source, but it's only open source if you're open sourcing your own software afterwards. And so there is risk that you ask an LLM to produce code for you, works great, you include that in your software, you publish your software, you start making money on it, and then some open source community comes and says, hey, that's our code, and now you can't monetize your code anymore. So that I just wanted to point that out, that you have to take that into consideration.
It's the same issue with artists developing some unique image or a unique something someone's written that seems really unique, and then someone says, hey, those 2 paragraphs come from my novel, or that was done in the style of my painting or something. Question.
I want to take us back to the previous question, and then maybe offer a slightly different point of view. If you had looked at the pictures and built a neural net in your head, I think we would have become a better doctor. We're all okay with that, right? We have no qualms about that paradigm. You can become a better doctor by looking at the same images and then getting a better fee somewhere else, or better like money or whatever to go practice somewhere else. We're okay with that concept. But because now you're using a machine, and again, you said locally, to train a neural net to do that same mental thing that you're doing, but on paper or a machine, now we have a problem with that, right? So I think it's not the same, unless you're sharing that data, unless you're sharing that code with some third party or whatever. If you're doing it for your own purposes to make you a better doctor, it doesn't really matter whether it's being done up in your brain or it's being done by a computer that you're using, or it's the same thing as you wearing glasses today, right? So
I need to write that statement in my next teaching. I like that. Basically, machine and the people now, it's blurred.
So slightly loaded ethical question. More than the use of the code that you're using, have you thought about the ethics of you using something like ChatGPT in the first place? Like, for example, the infrastructure that powers ChatGPT, data centers are often placed in really disenfranchised communities. The water that it takes to keep those servers cool, the electricity usage that these data centers have made communities not able to have like consistent access to electricity or consistent access to water. And it's like usually in places where people aren't listening to those people anyways. I don't know if you've thought about that, right? When you're going back and forth with ChatGPT, how much environmental harm or how much harm you may be causing to those communities. And it's a loaded question because like everyone's doing it. So do I just not do it to keep a moral like upstanding, or how do you like reconcile with that? And is that something you've thought about while you were working on this stuff?
Yeah, great question. Thank you. It's a question that I think, I mean, ultimately, I haven't thought about it enough. I think participating in this has kind of pushed me to reach into that space and kind of learn more about it. We had a brief discussion on Friday and kind of introduced each other, and I was like frantically writing down things I needed to learn and read between Friday and now, because I was like, oh my goodness, I'm so far behind. I don't know what I'm doing. And I maybe I read 1% of the stuff that we talked about, but no, I mean, I think anybody who's working with these tools has the responsibility to learn about how they are built and what they do. And then like, so to answer your question, I've challenged myself to learn more about it and to think critically about the use of this tech. I think part of that was this, looking forward to this discussion, right? Like kind of seeing everybody else's perspective. Where I work, or in the spaces that I work in, I work with a lot of people who are also focused on their day-to-day task and getting it done as efficiently as possible and finding ways to make it more effective. And I think it's good to collaborate outside of your specialty with folks who are maybe thinking about it from a different perspective. And so I think that's for this kind of thing is important for that. So thanks for the question.
But would you, if you had someone asking these questions on your design team for your product, would you want them on your team?
Wow, that's a loaded question.
Same.
Oh,
Yeah.
I can say that I would love having someone like that on my team. She's my student.
Nice.
really in his team. But I think that one of the things, if we need to think this way, and in a way, I'm very delighted. And I really say that a physician have a domain knowledge, and it was really, really needed. And their ultimate goal is saving lives. And we have the skin cancer, the wait list is 1 year long, at least, right? To be able to even see having that in session. So I think that if anything can accelerate and saving life, that is one thing I was thinking we needed to enable this kind of goal to do, to make the solution, and with also very fast, very small footprints. But well, you ask the your only crime is you ask the ChatGPT of how to make those codes. Okay, but
by having a team of like software engineers, having them figure out how to do that.
no, but then they yeah. So
I know, but you're paying in other ways, is what I'm saying. You're paying with your data exchange, you're paying environmentally. So those are, you're still paying. It's just how are we doing it and what are the ethics behind it?
But I think that this technology now really level the ground. And that's why my cohort has like 30, 40 students and coming. They are either radiologists and ER doctors and nurses. So I will just also say you actually go learn. And there's helpers now let you learn faster now, lower the ground of entry. Otherwise, they will never even come. This is just too difficult. There's no way I'm not going to do. So, but for them to have that skill, and it's very beneficial. Even you still have the software engineers and working with them, they become so much more efficient. That actually collaboration becomes seamless. So I think it's a very big benefit. Yeah, but you don't have to ask ChatGPT.
The reality is that, like, as a society, we're going to pay the price down the road, right? Like, right now, it's a great tool. It's very exciting. Like, anybody can have ChatGPT running on their phone and querying like whatever you want, like all the way from like a simple question about good restaurants in the city, all the way to like developing software for us, right? And right now, the global impact of these technologies is hidden behind the amount of money that these corporations are making and the amount of good news that they're putting on news channels, right? Because nobody talks about the societal impact. We only talk about how great these models are and how many people are using them, right? But just wait 5-10 years, right? Like, we're not even, right? Like, the reality is that we're going to start seeing the impact. Like, we're going to reach a point where our energy systems are not able to cope anymore. Until now, as mentioned, until now we're mining energy from underserved communities. But what happens when we can't produce energy anymore to feed these hungry beasts, right? Sorry.
Yeah, great presentation. I think the conversation so far has been pretty good. This is something that I think was maybe touched on a little bit earlier, but not answered. When we're making a tool that can, detect the presence of cancer in a tumor, right? And we're training this model on, hundreds of photos. If I'm someone from a certain demographic group that wasn't really well represented in those photographs, this system might not work as good for me, right, as it might for someone who was represented well in that training process. I guess the question is, how do you mitigate kind of this happening in a production environment? And how do you make sure that the data that you're training on is, well represented with different demographic groups?
Yeah, I mean, it's a great point. Largely what I've done has been proof of concept, right? I wanted to do it to show that it can be done. So for example, when I found these 211 cases to scan, I did a search on our system in London, Ontario of basal cell carcinoma frozen section. And I indiscriminately took those cases and I scanned them. I got rid of all the patient information and I just scanned the images. So and of course, like, as part of our ethics, what we do is we save a document that keeps information so that I have a key that we could go back and we could kind of deconvolute and find which case went to which patient, but it's separate. It's held separately. So ultimately, we could go back and get more information about the patients that these biopsies have come from. But in this early prototype or proof of concept, there is really no built-in protection against anything like that, right? The only protection is that it's entirely random in the sense that we are taking everything that is coming in London, Ontario, and indiscriminately using those cases rather than picking specific ones that we think look good or that have high quality, or the tumor looks like the agent will be better at it, right? So the idea is we try to use the data at random. That said, the population in London, Ontario may not match the population where this tool could be used in the future. And I mean, ultimately, to mitigate that, there's two ways you can go about it. One is using larger data sets that encompass a larger proportion of the population. And two, using data sets that are consciously chosen to incorporate all of the members of the population. And I'm not really sure the best way to go about that. And my expertise is pushing this forward to say, hey, I can do it, but I would need to collaborate with experts to see how to do it best.
For sure. Without revealing too much, have you guys already thought about this? Is this something that's been brought up already?
As far as moving forward with so I will say, I think that because I went from the basal cell carcinoma, the cancer detection tool, to the startup thing, those things are very separate. Startup actually has nothing to do with detecting cancer on tissues. But that said, we are looking from a research perspective to test this neural network in a local setting, in the same locality that the specimens all came from, at random. And so I think in some ways it's mitigated in our very sort of small, in our very specific situation.
Okay, thank you very much.
Yeah, thanks for the question.
I did have a question from the Zoom audience, and the question is basically, you're basically saying that we had the discussion that it's okay to use LLMs to gather computer science skills and to use those skills in developing your product. What about a computer science person or student who wants to do something in the area of health and who turns to LLMs in order to produce some kind of health-related product based on the knowledge that they get from LLMs? Would you be okay if the shoe, I almost said the foot was on the other shoe. If the shoe was on the other foot, would you be okay with that?
I mean, I ultimately would be aggressively pro having people with various backgrounds getting involved in pushing healthcare forward. I would probably feel the same way as I do about, in the opposite direction, that they should probably enlist an expert in the field early on in their project to make sure that they are not misstepping early. But I do think I don't see any issue with that. I mean, there are very specific, rules and regulations with respect to direct patient care that would have to be followed, and like, you know, you can't prescribe a medication because you built an app with an LLM. But that said, like, I think that I think I invite that. I think that's an excellent opportunity for collaboration.
Can I just build on that? I think one of the things I'm really excited about is the support for prototyping and exploring ideas. And I think that Josh did a great job of highlighting the potential of that. And so if you want to put the shoe on the other foot, I think it's totally fair to think about CS people experimenting with medical stuff in the sense of prototyping and exploring new ideas. And we've talked a bit about ownership of code, but we haven't talked about responsibility. So who's responsible when something breaks or makes that misdiagnosis or the misprescription? Right. And so I think that if we're very careful about setting expectations in terms of where AI is going to be making gains in terms of prototyping, exploring ideas, that's totally great. There was a blog post earlier this month, I'm going to forget who wrote it, but talked about the asymmetry of verification. And essentially the gist of it is that AI is going to make tremendous gains where we can easily verify the solution to problems. So where we have these big training sets on things like coding, no problem, AI is going to do a great job. When we start thinking about things like privacy or data sovereignty, much harder to verify whether your solution is correct. And so I think that we're just getting to the point now, after a couple of years of hype, of starting to be able to articulate what AI is good at and what it's not. And so I would just keep an eye on that space. Like, I think this is a really important discussion.
Hi, I am one of Dr. O'Gorman's students, and he knows how intensely pessimistic I am about the future. So this is another loaded question. I am very much for the advancements in medical technology, but I'm also very wary of the intersection of capitalism and health technologies. So, for example, if an insurance company was to use your technology to deny someone a prior authorization or a claim that they need a treatment, how would you feel about that? Like, for example, if there was a false negative with the cancer detection and someone was denied treatment, do you think that is an ethical use of AI technology?
Yeah, so fair and loaded question. Appreciate it. I think, I don't know, I have a hard time getting away from the sort of medical ethics framework that I'm trained in, right? And so there was a mention of responsibility earlier. And so ultimately, the tools that, like that specific tool I built to diagnose or detect cancer, that is kind of like was said earlier, in my mind, not too much different than developing a microscope that has a bit better of an optical range, or developing a technique that improves your eyesight to be able to detect the tumor. Ultimately, the responsibility remains on the physician to make the final diagnosis. And I don't think any of what, or like, I can imagine, you know, there's always ways things can be co-opted to go the wrong way. But in the way that I've imagined this technology would be used, that ultimately the physician still maintains the responsibility for the ultimate diagnosis. That said, is there a situation where this technology could be, I mean, I can imagine that that could happen, and no, I wouldn't feel good about it. And, you know, as physicians, there's an element, not so much in Canada, but abroad, of, you know, fighting with insurance companies for coverage and things like that. And physicians are active and loud advocates for getting appropriate patient care. And so that would be, you know, it would kind of be a travesty if this technology was used to deny a patient access to appropriate care. But again, ultimately, I think it's the responsibility of the physician to make the final call.
This is another new question. because the assisted technology for any diagnosis has been existing for a long time, right? Just like you could you say. But I come back to a new era of generative AI, large language model. I want to reflect back to what Jim was just saying, is that now the evaluation, the tools, the methodology, it's new. And it's not traditionally software, and you give them A, they always give you A. Now you give them A, ask them 10 times, and they give you A, B, C, D, E. So if at a scale, how you're going to actually ensure their data is reliance and etc. So that is where we are doing now. And I think I welcome people to join us to actually advance that kind of technology and framework, etc. I think that's very important. And second, I actually want to mention, and you are very brave, you actually went to write to the code. But now I see another type of actually direct involvement, and I'm recently involved in quite a few of the chatbots technology deployed in the health unit, public health, and all for the subclinical mental health help. That's one of the chatbots actually was used in Waterloo in the wellness, campus wellness. So that kind of actually training the chatbots, we call the co-design. And then the psychologists and psychiatrists, they don't need to go into the code, but then they just using the right prompt and using their rule articulate, and they actually can make that chatbots much more usable. I think that is another way of your vibe programming without really writing code. Right. But that's so important for the clinicians and directly involved in terms of actually putting the boundary, getting the edge case, and also looking at the right prompt to actually configure that chatbots to do exactly what they need to do. So I thought that is another style of web programming. So I thought I just want to bring this and out as well.
Well, we are over time, and Josh has been in the hot seat for way too long. I know there are more questions in the room and online. I'm sorry we couldn't get to all of them. If you're in the room and you want to ask a question to Josh, please come up after and ask it, not in front of a big audience. And if you're online and you want to ask him questions, I can ask him those questions. We may not get back to you, but I can still ask him. So thanks everyone for coming, and we look forward to seeing Josh as a champion of ethical AI with this new startup company and modeling that for everyone else. But thanks to this whole group for coming today and to all of you.